Hi guys, hi everyone. Thanks a lot, PyData Global, for receiving me. I just got the bad news about the Portugal match, so I'm a bit shook still, but I'll try to make the best talk possible. So yeah, my talk's called MLOps for the rest of us, a poor man's guide to putting machine learning models into production. So first of all, who the hell am I? What am I doing here? My name is Duarte. That's a Portuguese name. I'm a machine learning software engineer, also a contractor. I'm originally from Lisbon, but I'm based in Copenhagen, Denmark. In the past, I worked in strategy, product management, new ventures, management consulting. So kind of a lot of different positions. Now I write code and try to solve problems end to end. And the final thing about me is that I like running a lot. I run like 3 marathons every year. I'm not sure if that's going to last a long time, but we're here for that. And yeah, I just wanted to also a shout out to PyData Copenhagen Meetup, which is here in Copenhagen, which is also an awesome meetup that I host and I go to almost all the time. All right, so let's get to it. So this is a talk about helping small teams cut through the the thing. And there's a couple of topics I'm going to talk about today. First of all, LinkedIn, how you're probably not like them. We're also going to talk a little bit about cutting through the MLOps hype, how to deliver models in production. That's going to be the core of the talk. And it's a lot about unsexy ML, kind of boring ML, like some people call it. And of course, in this talk, there's a lot of opinions, so many opinions. This is all from my experience. So I only know what I've seen. So there's a lot of these things you can think it's wrong, doesn't apply to you. If there's any problems in that, there's my website, there's my Twitter. Reach out to me. Let's have a productive discussion about it. And so, yeah, just grains of salt. Remember to take a lot of them. So first of all, LinkedIn. And I'm actually going to tell a little bit of a story here. I remember once I was working on a recommendation system and I was super excited, like recommendation systems, that's all the hype. I'm super excited about getting started and just delivering this recommendation system to my client, like it's going to be great. And I saw that there's one of these big, large tech FANG companies giving a talk about how the hell do they build recommendation systems. And I was super excited. I'm like, okay, I'm going to go to their workshop, learn all there is to learn about recommendation systems, and then I'm going to be the best ever. I'm going to kill this recommendation system and make the life great for my user. Unfortunately, like 10 minutes into this workshop, I was not understanding a single thing. There was this machine learning engineer coming in talking about things I've never heard about. And so I was kind of like, okay, I don't know anything that's going on. I don't know how I'm going to do this. I don't know exactly what I can do. I'm clearly not an expert in recommendation systems. I'm fried. And in the end, I still ended up delivering that recommendation system. So my point is, you're not LinkedIn, you're not Facebook, you're not Apple, you're probably not Amazon. And the caveat here is maybe some of you are, but you kind of get my point. This is a talk about those of you who are not. And the point here is that they have probably 600 machine learning engineers. I actually Googled this for one of these companies, and they have more than 600 machine learning engineers. They have dedicated teams for everything you might think of. They pretty much own the public cloud. They don't use the public cloud. They own the public cloud. They have research teams looking at the edge of research and development of machine learning. They even sometimes have a machine learning platform team who just makes their goal to make a platform so everyone can use and things like that. And then there's you, or at least me, which normally I work in teams of like 4 people, maybe 7 people. Then dedicated teams, it's basically me. I don't always have a data engineering team and whatever other specialized teams kind of helping me out developing models and delivering models. And I don't own the cloud. I'm trying to keep costs down while I'm using the cloud. And it's not that much about research as is it's more about delivering value. And it's about delivering that value fast. And yeah, ML platform team, lol. Like I wish I had one. I don't. Maybe I'm building one as we're talking about it, but still. All right. So that's the first part about those companies and how you're not them. Now let's talk a little bit about machine learning operations. So For me, machine learning operations is not about adopting tools. It's about delivering value. We've seen this gold rush age of machine learning operations. Here to the right, there's an image of the number of machine learning operations tools and how they've just rose from 2008 to 2020. So we have more than 300 machine learning tools for all types of specialized things like hardware, modeling and training, serving. Like, we have a lot of tools, and there's a lot of fear of missing out, like FOMO, right? I mean, I should be using some of these tools, and there's a lot of spam emails going around of people trying to use certain tools, and so there's a lot of this focus on the tools. But the reality is that only 22% of companies have put machine learning models into production. And so the real problem that I see is the problem of providing value. It's not so much about the tooling, but it's much about the value. And one thing that always happens to me is that people come and they're like, okay, can we make this model in a couple of weeks? And if I apply the machine learning operations mindset straight away, I think this. Okay, that's a lot of things. We have a data pipeline, a machine learning pipeline, a software code pipeline. We have the monitoring and the logging. We have the model decay trigger. We have the feedback, the data versioning, the profiling, the hyperparameter tuning. You know what I'm getting at, right? It's a lot of different things. So it's a little bit unrealistic that you can develop all of this in 2 weeks. I mean, it's a bit unrealistic. So how do I, and so my experience, how do I think small teams can solve small scale or reasonable scale machine learning problems? So we have 6 sections: people, data, start small, production, monitoring, and machine learning platform. And let's talk a little bit about the people aspect of this first. So machine learning operations, we've said this, it doesn't really start with the tools. It starts with the people. People will come up to you and they'll be like, we need an ML model. And this is very similar to the sentence, we need faster horses. And when people really wanted was cars instead of faster horses. And at the end of the day, you are the specialist, the machine learning engineer or the data scientist. So be skeptical if you can when someone's asking you for a machine learning model, because there might be a possibility that they don't want a machine learning model, that they want a heuristic solution or a software solution. So you as the specialist can try to ensure that the machine learning model is the solution to the problem. A lot of times I try to think less of giving solutions and think more of giving a partnership to whoever I'm developing a model or problem or solving a problem for. And there's a great book by a great blogger that I like called Derek Sivers called Hell Yeah or No. It's a lot about a lot of different things, but it also talks a little bit about this notion of saying no, which I think it's a super important notion, especially when you're dealing with clients or high pressure projects. And I also always give the advice of don't build in the basement. A lot of us machine learning engineers, or let's say nerds in general, have this idea that I'm going to build this model. I'm going to go into the basement or into my room for 3 weeks. I'm going to talk to anyone else. I'm just going to do my work. And then I'm going to come out 3 weeks later and you probably have a problem. And probably something didn't really quite work. And your client or your team or your manager is going to be super surprised. What the hell? It didn't work. And that's because there's a great value in communicating regularly with whatever problem you're solving. And especially in machine learning operations, where these are super tough problems to solve, you need to keep your team or your client continuously in the loop. Hey, every day, every 2 days, here's what happened. Here's the difficulties I'm facing. Here's what I think we can do to solve them. And in the end of those 3 weeks, nobody will be surprised. They'll be exactly on the same boat as you, and it will make a lot of sense. So my advice is, if you can have some sort of control over how you're going to build this thing and how you're going to kind of project manage this, don't build in the basement. All right. So let's talk a little bit about data. So data is super tough, right? Like if you're a small team, if you're not Fang, you probably don't have the data. You got to go ahead and you have to go and label that data, which is a tedious process. I'm sure there's a machine learning operations tool out there somewhere for that. And people always talk about this thing about continuous learning, right? But they forget that the only problems that you can apply continuous learning are problems where you have natural labels, not all problems. And you probably have a very small number of labels. And this is tough, right? But don't despair. There's a lot of ways to tackle these problems. Like if you don't have the data, scrape it, annotate it. Um, if you have a label something, things like embeddings, PCA, similarities. There's a great project by Vincent Warmerdam on the bottom left there. And also for the continuous learning, make sure you capture feedback really early for your model. And if you have a small number of labels, zero shot or embeddings or fine tuning are great techniques to apply, especially in NLP. And this is one of the books I've read this year that I really enjoyed. It's Natural Language Processing with Transformers by O'Reilly and by Louis Turnstall. And it shows these two concepts that I really enjoy. The first one to the left is this nearest neighbor notion, that you have a bunch of data points. And if you have a new data point, you can just look at its nearest neighbors and you'll probably infer a good enough or reasonable enough label for that point. And pre-trained embeddings are a great technique to use for that. On the right side, there was a test that was done in this book of applying some techniques like fine-tuning, embedding, naive Bayes, zero shot, and how many training samples you had. And these guys, with only 223 samples, using fine-tuning, they can achieve already an F1 score of 70% or 0.7, which is really good. So you don't need that many labels. Labeling 223 examples doesn't take more than a day, in my opinion, depending on the complexity of the task. But you get my point. So there are great ways of dealing with this data issue. What about starting small? I normally, in most of my projects, I use a combination of PyProject, and that's to the left. That's pyproject.toml. That's PEP621, which allows you to define your project dependencies in a pyproject.toml configuration file. And here you have the build system, the project, and the dependencies that I use, and the optional dev dependencies. And the thing about pip tools, which is a tool that was developed by Jazzband, one of the core teams at Django, is you just write pip compile, and then the requirements txt in the pyproject.toml, and pip tools will automatically generate a requirement txt file from that pyproject.toml. So you could just do these two pip compile commands, one for the dev requirements and one for the normal requirements. And just from those specifications on your PyProject, you have your requirements txt done. I know a lot of people like poetry. A lot of people like Anaconda. I don't. I like lightweight. I like things that work on Docker containers and are kind of fast. And this has proven to be really, really robust for me. So definitely advise you to give that stack a shot. Okay, what about testing in machine learning? Test enough to increase confidence and ensure production does not break. That's kind of the main thing, right? So most of these cases, PyTest is fine. And here on the left, you see an example of me using a PyTest test to test a classifier. And I use this parameterization of tests. You can see like this PyTest or mark parameterize and text and then the expected class. And I test the obvious, like I hate this, should be the class pissed. This is cool, should be the class chilled out. But I also want to test the edge cases. What if someone gives you an empty string? What if someone gives you a null? What if someone gives you an int? Are you still making predictions? Because you probably shouldn't. So testing those edge cases, just enough to increase your confidence and also knowing that your user is not throwing anything at you and validating user inputs, it's super good to do. And it's extremely easy with PyTest and parameterized tests. There are some other techniques, but this one works fine. And then I use make files. Make makes things simpler. So I have this thing that in most of my projects, I use make files. And what you're seeing on the screen is basically a make file. And it has a couple of commands like install dev, build, clean, flake, format, etc. And each one of these commands runs a set of subcommands. So make clean removes all of like the cached files and stuff like that. And there's a neat trick where you can add kind of a little snippet to your makefile, and I've included that URL on the bottom left. And whenever someone comes into your project and writes make help, it will get automatically the comment for each one of these commands. And it's like a map to all your project. So writes make help, sees like on the bottom right, all of your options. And then I went, okay, make install dev, make test. And so it's a super easy solution for anyone that comes into your project, knows instantly what they can do inside of your project just because of this little makefile. I think makefiles are a thing from, a lot of people think makefiles are a thing from the past. They probably are a thing from the past, but hey, so are terminals and they work perfectly fine, right? So I normally love using makefiles, and that's kind of the standard I've used, and people that work with me really like. All right, I also use a lot of CI/CD in most of my machine learning projects. So CI/CD increases the confidence, but also enforces the standards that you want to set in your project, especially when you're collaborating with other people. And to the left is an example of a CI/CD pipeline using GitHub Actions, like we set the action up. Then we reuse those makefile, those make commands that come really handy, like make install dev, make check, make test. And then on the right is an example of that pipeline, right? You have a first part of the pipeline that just checks your code, builds the environment, does the linting and formatting, because I don't want to have discussions about single little double quotes or just one little quote, and does the unit test. And then once your code is checked, then it builds the container, deploys it, and also tests the API. And there's a little integration test. So you check your code and you deploy your code. And this is super easy to set up, especially if you already have all of the make commands kind of set up. It's super easy to set up. And I definitely advise you to use something like CI/CD for your projects. All right. What about production? So I normally like delivering containerized models, leveraging the public cloud. Normally that involves using something like FastAPI and PyData. And PyData is really great because PyData allows you to define exactly what your API is going to receive. So on the top right, I see an example of like features like sepal width, sepal length. And PyData ensures that they are afloat between 0 and 1. And whenever they are not afloat and between 0 and between 1, my API does not accept that request. And so all of those edge cases and things that can go wrong are automatically eliminated by PyData. And FastAPI also provides automatic documentation and validation of user inputs and outputs of my API. I also normally Dockerize most of my APIs, machine learning APIs, and it's been working great. And here on the right, you also see an example of that Docker file. Again, we're using that make file, and now it's called make production. And then you have all the installments and stuff, and your Docker file becomes really lightweight, and it works really nicely. And there's also a little bit that I want to talk about choosing the right cloud. I think there's a lot of science, especially in machine learning, MLOps, and for data scientists and machine learning engineers, of knowing how to choose the right cloud service. And choosing the right cloud service really matters. You have essentially, I'm sorry about the lecture here, but you have essentially 3 types of cloud services you can use when you want to deploy something, right? You have the EAS, which is like SSH into a VM, EC2, Amazon. You have the Run My Container, like the platform as a service, the PaaS, which is something like Cloud Run or Fargate or Azure Containers. And then you have FaaS, like Functions as a Service, which is Lambda, Cloud Functions, or Azure Functions, where it's basically, run my function. And I've made some examples of some of these types of services for each like big public cloud, but they are all pretty much the same. Honestly, on the bottom left, there's a little website called comparecloud.in. You go to that website and you can see exactly what Lambda functions means on Azure. And you'll notice very quickly that they're all the same. And so you have these 3 types of services, right? And the difference between these is that the public cloud provider or you control different aspects of this. For example, on EAS, on SSH into VM, you control everything, from the function to the app to the runtime to the OS. On Functions as a Service in the other spectrum all the way to the right, you only control the function. All the app, the runtime, and the operating system are controlled by the public cloud provider. There is no best cloud service. If you go to functions as a service, they're more scalable, but you also have less control. You only play when you pay when they are on, but sometimes they are kind of underpowered and they take time to light on. And there's no hardware, right? And that can be a pain. On the other side, on like IS and like VMs, it's more powerful. You have more control, but you pay for the whole month. And when you're using a GPU, that costs a lot. And so it's very powerful, but also has like bad things. And so normally I tend to start with functions as a service and then start going into ES, the more complex the project gets. Normally my sweet spot is around paths. Like, hey, here's my container, run 50 of them if you need. That's really helpful. So normally that's what I go for. And let's talk a little bit about monitoring as well. Essentially for me, there are 3 types of monitoring. So I've drawn this sketch and like, here's my machine learning application in this green box. The first monitoring you do is like logs and error monitoring, like something like OpenTelemetry. I just want to know if something breaks in my code. And so you do that. What I also do in mostly my APIs is that I actually store all the inputs to the API and the outputs of the API. And I store them in like BigQuery or something like that. You see the little red box and I just store them down. And this is really nice because it allows me to do 2 types of monitoring. The drift monitoring, looking at what I've predicted and my training data set, but also for business purposes or for reporting or whatever, I want to know how many cats I predicted for the last month. And so I can also take those historical predictions and put them in a dashboard, like a Metabase or, I don't know, Supercell or whatever you're using. So essentially, you have the drift, you have the logs, the error monitoring, and then the business reporting. Those are kind of the 3 aspects. And it's relatively easy to set up all of them as long as you're like saving everything, basically. And so we can actually talk a little bit more about this. I want to also talk about the drift monitoring aspect of it. Evidently, it's like an open source tool that I use, and it's super easy to set up on the same kind of route as your API. And so normally, if I have a machine learning API, someone can go to /routing, and it automatically shows a drift dashboard. On my website, there's actually a blog post just about that. I don't know if it's the recommended way of approaching things, but you can send me an email and tell me what you think. Okay, what about ML platform? Well, big secret, there is none. There is not a machine learning platform. It is a cookie cutter template. I've come up with this set of ideas and this set of concepts and things that I enjoy and have been working for the past years and have evolved over time. It's a template that evolves with my practices and what I've learned. And you have the GitHub workflows, the Docker file, all your notebooks and requirements and your source code. And we just use a cookie cutter and we apply them to different projects. And that cookie cutter evolves. I don't call that a machine learning platform, but it's a template that has been working a lot of times in a lot of different microservices and APIs and machine learning models that I've built. And it works incredibly well. So I encourage you to use something similar. Cookie Cutter is a great project. If you don't know what it is, it's basically a repo template that asks you some questions, and then you can all get started. And so, yeah, that's a little bit about my my platform. Let's put it like that. All right. Okay. So, what's the point in the end that you're trying to make, Duarte? So, my point is, first of all, you're not LinkedIn. Embrace it. That's good. It means that you can do a lot of different things, and I like when things are tough. So yeah, enjoy it. You enjoy the freedom of like putting 5 hats on. Boring technology is good technology. I like tools, and I believe that you should use tools, but you shouldn't use tools for tools. You should use tools when you need something that you're not that really has lots of value. So just don't go straight into the tools. Then MLOps is about delivering value, not using tools. And so squeeze all the juice you can possibly squeeze from the tools you have, especially in small projects where things can change from day to night. Yeah, so I hope that was helpful. And thank you very much. Let me know if you have any questions.
Yeah, thanks, Duarte. We have a Yeah, we'll take a few questions. Yeah, so one of the question by Thiago. For your three types of monitoring, any thoughts on choosing the right database, SQL
Oh,
versus new SQL?
great
Sure.
question. Tiago, go with JSON. Like, go with the most unstructured thing you can find, because your API will probably change with the course of time. And if you go to like an SQL database, you'll need to adjust or do some migrations on that database with time. If you just store JSON, like it will always be JSON. So whatever fields you add or remove can change over time, and that won't affect your dashboards. So I would normally go for NoSQL. But I mean, I don't know how much data you're handling, so maybe it's like undoable. But yeah, go for NoSQL for sure.